old. No, the sleep has not finally caught up to me, Liam. No, it has not. However, I tell you what did catch up was my leg, my knee has kind of given a bit of pain, and I couldn't go to school today. So I was like bored as hell at home, and I was like, oh, why don't I just do a probability level 3 video? And then I did that, and then I was like, oh, why not just do a level 2 video? And then I was like, yeah, so it's all right. I got a bit of work to do. I was driving past the Auckland half marathon yesterday, and I was like, I looked at those guys running, and I was like, man, I gotta go back to running again. All right, so we've got 2 excellence questions today, and I've actually picked, I think, so Jacob, I don't know if you're here on the chat yet, but I reckon we can do the question you sent as well, because it's pretty much the same type of question. Now look, the differential equation, the word questions, they tend to be like bread and butter, right? There's only so many things they could ask, and there's only so many different varieties of these types of things that they could change. All right, so we're going to try this question. What I might do is I might actually do Jacob's question first, because that one they actually give the formula. No, let's do this one first, and then we'll do Jacob's one. All right, so with this question, what I'm going to do is I'm going to give you folks about, I think 5 minutes is more than enough to do this excellence question. I will give you 5 minutes, but what I'll do is after 9:05, I'll give you the first clue for the line. So if you're still stuck, at least you've got a 2-minute window to kind of give things a go. And then at 9:05, I'll give the first clue, and then we'll work from there. Yeah, the level 2 grind has been insane. I think when I posted it, I should have posted the stats from the other remaining 306 days. So I've had 1.2 million views over 306 days. But in the last 2 days, I've had 100K views. It's just insane how this graph is actually going. Yes, this is Newton's law of cooling, Mars. Like the stats has just been like so much fun to kind of watch. I mean, I know I sometimes complain about stats, but and it's all level 2, because check this out, it's like 105K views in the last 48 hours, and that's like the other guys. But then it kind of nicely starts coming at 8 o'clock. People start studying this morning, and there we go, we're kind of averaging, and then boom, 8 to 9, and it's all level 2 stuff right there. Yeah, it is. It is a nice bit of money for like 2 days, and then I go back to like 20 cents a day. All right, so 9:05, here's the first clue. The first clue for you is, remember that this is actually looking at Newton's law of cooling. So we've got the big T, which is the temperature. So we're going to do dt over little t equals to K. And in the bracket, we've got the room temperature of 47. That is your first hint of today. And I think that should be more than enough, because once you have this, then it just becomes that whole bread and butter things. Now this formula is, I don't think it's given in the exam, Mars, for Newton's law of cooling. Let me just check. I don't remember seeing Newton's law of cooling in there. Nah, they don't have Newton's law of cooling in there. That's just something you have to remember, Mars. Now, look, there's only two types of equations. It's either KT or KT minus the room temperature. That's it. Like, those are your kind of like two Newton's, like, well, not the differential equation questions, right? There's the Newton's law of cooling, which is this. So you always go KT for your normal differential equation. But for this one, for the Newton's law of cooling, you just go K bracket T minus the room temperature. So in this case, that's 47. Nah, trust me, I think you'll be fine with this, Mars, because I think like once you get the hang of these questions, like you'll be fine, because I know you haven't finished the integration playlist, and I think we only do this right at the end. I think it's episode 15, I think, is when we do this. So yeah, you'll be fine. All right, I'm going to slowly start working through this. So remember that with differential equations, we want to actually separate the variables. So here I'm going to write this as dt over t minus 47 equals k dt. Yeah, I get it. I need to put this to mute. 47.96. Oh, Lauren, I got a different answer, Lauren. Yeah, I thought you would get that straight away. Is it Jason? Sorry, I'm Jacob. No, I'm forgetting names here. Jacob, yeah. Jacob, yeah. I think once you get that, you'll be all right. 53.2. Yeah, that's looking a lot better. But why do they have 56.07? All right, anyway, let's actually work through this. 53.3 sounds a lot better. So our next step is we're going to actually integrate both of these sides. So on this side, this is going to become ln of t minus 47 equals kt plus c. So once we do that, we are now going to get rid of the ln. So we're going to get t minus 47 equals e to the power of kt plus c. And this is the bread and butter stuff that I talk about. And then your next step is you would just write this as, I don't know what that word, I think I might just go t0 ekt. Because all I've done here is I've just separated that e to the power of c. Because remember that e to the power of kt plus c could be written as e to the power of kt times e to the power of c, and then e to the power of c can be written as t naught. I'm going to write it as t naught. I mean, you guys don't need to. It's up to you, whatever you want to do. So that's what it comes from. Maz, yeah, that's ln. When we want to get rid of ln, you got to put in the e. All right, so now what we have is initially item that has a melting point of 1370. Once melted, the liquid is polar. Okay, so that means when T is equal to 0, the temperature equals to 1370. Keep asking, Maz. I'm sure these guys will help out as I go through. So then we've got 1370 minus 47 equals T naught E K times 0. So we're going to get 1323 equals T naught. Now e to the power of 0 becomes 1. So T naught is equal to 1323. Okay, that's good to know. 53.1 is probably what I'm looking. 53.21, but it doesn't matter. Like, look, as long as you get the answers as close as possible, then you're good to go. So I figured out what T naught is. I need to figure out what the K value is. And I think the way I'm going to figure it out is at 10 minutes, the object has cooled to 850. So when T is equal to 10, temperature is equal to 850 degrees. So I'm going to go 850 equals, no, 850. So my equation was that T minus 47. So I got to go 850 minus 47 equals 1323 e to the power of k times 10. So I'm going to get 850 take away that. So that's going to be 803 equals 1323 e of 10k. Mars, if you have a look at it, you'll see what I'm going to do with that e of x. So then you got 803 divided by 1323 equals e to the power of 10k. Now, we want to get rid of the exponential function, so we're just going to take logs of both sides. And when we do take logs of both sides, with ln of e, they just cancel out each other, and you're going to get 10k equals to that. So then I can say that k is equal to ln of 803 over 1323 divided by 10. Now I want to show you guys this little trick here so that you don't have to worry about rounding answers or like getting incorrect answers. So in your calculator, what you do is you put in, let's get rid of all of this. I hate this function. So we're going to do ln of 803 and divided by 1323. And I'm going to put that all as a fraction as well. Oh no, it's doing that. So I'm going to have to go divided by 10. So my k value happens to be negative 0.499. Now, what I can do is, and this is a little bit of a trick that I can do, and I think it works like this. I could go take this answer and then put it to alpha k. And basically, every time I use alpha k, I'm actually going to get this negative 0.499. All right, so in my actual working out, I might just write negative 0.0499. But on the calculator, I'm going to actually use the k value. All right, so now what we need to do is we need to figure out what time it's going to reach 140 degrees. So we're going to go 140 minus 47 equals 1323 e to the power of negative 0.0499 t. So 140 take away 47, that's going to be 93. So we got 93 over 1323 equals e to the power of negative 0.0499 t. Then we take logs of both sides. So 93 over 1323 equals ln of e just disappears, and we're going to get 0.0499 t. And then t is equal to this ugly log function divided by negative 0.0499. Now, because I actually stored the k value, what I'm going to do is I'm just going to go ln of 93 divided by 1323, and then I can just go divided by k value, which is alpha k, or I could have just used answer as well. And what happens is I get 53.17 minutes. All right, so let me just put up some line numbers here, and if you do have any questions, feel free to yell out or call out the line number. But like I said, this is your standard bread and butter Newton's law of cooling question. And the only thing you need to remember is this part here. Cusack Films, are you doing probability 3 or 2? Now, Barry, I think K would be negative because it is actually decreasing, so it's not increasing. Chris, I got one more question to do today, and then I'm gonna call it because I've had literally I've spent the whole day making videos, and Ty doesn't understand line 2. Tate. I can't see Ty's comment. Line 14. What happened with line 14? All I did was I took ln of both sides, Dahlia. So when I take ln of e, it just cancels out each other. So imagine like it's like taking square root of a square number. It just cancels out each other. Oh, right, you're talking to Mars. Right, sorry. So imagine like this, right? Let's say you have e to the power of 2, right? Now, if I actually take ln of e to the power of, I don't know, 23, I'm just going to get 23 because ln and e, they're opposite functions, so they cancel out each other. That's what's happening in line 14. So in line 14, let me just expand to line, I'm going to do a line 13.5 so you can see it. So when I take ln of both sides, I'm going to get ln of 803 over 1323 equals ln of e to the power of 10k. Now the problem is ln and e, they kind of cancel out each other, and the 10k just drops into the lower line. That's what's happening at line 14. I'm not sure what do you mean by Jeremiah? Like which line are we talking about? Welcome, J. Crow. Intuitively, why would T naught equal 1370? That is because we have to always consider the room temperature has an effect on the rest of the the actual temperature of the thing. So that's why we don't, when we do Newton's law of cooling, we always never put T naught as the original value. We've got to consider the room temperature always. Line 1 is something that you need to remember, Ripstick, because look, when was it that I did this? An integration 15-hour playlist. Not 15. God, I hate trapezium rule. Yeah, I think I did like Newton's law of cooling. This yellow, the formula in the yellow box is just something you just need to remember. Just like how in 13, did we do 13 or 12? No, not in 12, maybe 11. Yeah, like see, we talked about the proportionality for differential equations. So we talked about it in 11 and 14. Those two formulas you just need to remember, and all you do is just substitute it, and then you pretty much just do the bread and butter part of it, which is just repeating the same things. So Ripstick, hopefully that line made sense now. Now you have to do that, Jeremiah, to go from line 3 to line 4. You have to get rid of the ln, because you have to take ln for that, otherwise it doesn't actually work. Kevin, what might help is have a look at the calculus integration in 15 hours playlist, particularly episode 14. I think I cover quite a bit of that if you want to catch up on it. But we're going to do another question, similar question like this. So you're welcome, Durian. All the best, man, for your exams tomorrow. Oh, yep, Chris, just email it to me, mate, and then I'll add it to the list, and we can do it tomorrow, because tomorrow is complex numbers. Just title it level 3 complex, because then it's easy for me to just filter. Yes, I do have a new email address now. I got subash@infinityplus1.co.nz. It is official. Maz, if you do want the notes, I've also shared my OneNote in the... Is it on the link? Oh, no, it's not on the link. Okay, let me just share the OneNote. then you guys can always just it's been embedded into all my new videos. The old videos, I need to add them, which I haven't done yet. Lazy Bashi. So Maz, if you do want to grab my OneNote, which does have my notes there, I'll put it on the description of this video. And I'll put it up here as well. So you can just go there and then go to level 3 integration and go to today's date, and you'll see all the notes there. Dahlia, it's just I had to bring two of my websites together because one of the issues that I was having was like people wanted to support, but you know me, I'm like I don't want money for free, so I'd rather make something. So I'm gonna bring my Infinity Plus One store and the YouTube one under one website. So if you have some people, family members you can recommend my website to, you can. I'll make them something nice. Sylv, TO in line 5, I've just made that as an initial value because I think I explained how I got the TO here. Just this entire part. Actually, no, not that part. This part is expanded a bit more here. So you can have a look at how I did it. E to the power of C, yeah, it'll always be written as a constant. And so that's why I wrote it as TO. I mean, you can write it as A, you can write it as P. It doesn't matter what letter you write it as long as you know that's the initial temperature there. All right, I think we're ready for the next question. You can leave it as C, Kevin. Yep, you can leave it as big C if you want to. Yeah. All right, let's try the next question. It's all right, Maz. Don't have to worry. But I don't know if Jacob sent me the schedule for this. Now, in this particular one, I'm sorry, this is the best I can do in terms of lighting for this question. In this one, you're actually given the what do you call it? The formula, which is actually quite nice of them, but you don't really need to worry too much about it. All right, got it. Got it, Jacob. Yeah, we're doing a double Newton's law of cooling. Then I don't ever have to do Newton's law of cooling ever again after this tutorial. What do we have as the final answer? I'm just looking at that. We've got 151.48. Ah, Jacob, you got to send photos that I can actually keep. It just disappears and I've lost track of it. Yeah, in this case, TA will be room temperature, Maz. Yeah, I think they do explain everything in this. They are very generous, J. Crow. I think that's why it's... Yeah, I tried hold open, but it's... No, it's completely gone. Come on. Oh. Thanks, man. Appreciate it. That's better. Why is my... what do you want? 151 and 29 seconds. Amy, man, that was super fast. 151.48 is what I've got here from the answer schedule. So I think you're pretty much good to go. This is a nice question. I'm not going to lie. Unless Amy's already done this question and she's just got the answer in front of her. She must have it. No. T minus 22 is equal to ek per t plus c. Put e to the power of c as t naught, Maz. Now, Dahlia, I think the examiners, they always like to kind of make questions a little bit tricky in the sense where, like, it's like one little thing, right? It's just one little thing that's going to make you think slightly different, and then the rest becomes easy. I think that's what a really good question is. Like, I find that when people come and complain to me about excellence questions being really hard, and then I'll show them like one thing and they're like, ah, yeah, that makes sense. I think it's because, you know, we've got to do so many more questions, and I think the more questions that we do, the more exposed we are to these types of questions and the tricks that they could potentially pull on us. So yeah, it's just all about just kind of giving things a go. I haven't read the question yet. Interesting. So the oil can only be returned at 40. Oh, you cheeky boys. They haven't actually given you T naught in this question. Mars, that's the end question. I see what the problem is. They haven't given you the starting point in this. So this is the other version that they do where they trick you, right? Yeah. All right. So I'm going to actually have to work you through this one. So the thing is, well, that is bright, isn't it? That yellow just makes it kind of pop. Let me just grab some information down here. So I've got T is equal to 15. Temperature is equal to 283. When T is equal to 45, temperature is equal to 167. And I want to know blah blah blah, what is T when the big temperature equals to 40 degrees. I don't think you need to read the question. That's all the information that you literally need to do this question. They've given you the formula, which is still our standard bread and butter integration, which is KT minus, what's the room temperature at? 22 degrees. Okay, so this is all the information that we're going to need for answering this particular question. Now, Maz, yeah, you're right, Maz. T naught, we can't actually find T naught in this case because they haven't actually given us T naught. But instead, what they've given us is 2 different times and 2 different temperatures, which means we've got to actually use simultaneous equations to figure out what the K value is. Fun times. And then once we figure out what the K value is, then I think then we can figure out what the T naught is. Now let me show you. So let's integrate this first. So we've got dt over t minus 22 equals k dt. And as I said, this is your normal bread and butter stuff. So that's ln of t minus 22 equals kt plus c. Then t minus 22 equals e to the power of kt plus c. And I think this is where we kind of get stuck, right? Because we don't really have anything else to do after this. So we've got 15 and 283, and then we've got 45 and 167. So we're going to actually set up an equation here. So let's call it T naught, right? So if it is T naught, we're going to get EKT like this. And I'm guessing this is where you guys are up to. So the next step is we're going to use the 15 and 283. So remember, 15283 is one of the values. So we're going to go 283 minus 22 equals T naught EKT. So here we're going to get 261 equals T naught EKT. Gonna do the same thing for, what else can we do here? No, nothing else. And then do the same thing for 45 and 167. So we're going to get 167 minus 22 equals T naught. What am I missing here? Oh, I'm missing the 15. T naught EK45. So this is going to become 145 equals T naught EK45. Oh, that's an interesting way of doing it as well. You could do that as well, Amy. Does it still work out though? Does it work out, Amy? Huh. I don't see why it wouldn't work out. Let me know, Amy, if that actually worked out, because I'm just trying to think of it in my head. So you've just substituted 15 minutes from, yeah, I can see how that works, because what are you doing? You've shifted the entire graph by 15. Yeah, I don't see why it can't actually work. I actually like that thinking. It's actually really simple. Amy, definitely, I think that folks, what Amy did here was that she actually went like this. See, when t is equal to 0, big T is equal to 283. Then she went t is equal to 30, big T equals to 167. And then here, when she found out whatever t was, she just added 15 minutes to the end. That's such a clever way of doing it. I gotta hand it to you. But anyway, look, we're kind of halfway through this. I might as well show you how to do this the simultaneous way, because all you have to do in this case is TO equals 261 divided by E15K, and then in this side 145 divided by e to the power of 45K equals TO. Now, because TO is equal to each other, I could actually say 261 over E15K equals 145 E45K. And then cross multiplying, I get e to the power of 45k over e to the power of 15k equals 145 divided by 261. Then remember that e is a base, so that means when I divide with the same basis, I subtract the powers. And I've got 145 over 261. Then I've got e to the power of 30k equals 145 over 261, and then 30k equals ln of 145 divided by 261. Amy, can you tell me what your k value is? Because I'm curious to know how this actually works out. So then K is equal to ln of 145 over 261 divided by 30. That's what I get K as, but I want to know what you got K as, Amy. $261 divided by 30. I want to know if you get the same K value. Did you get K value as negative 0.01959? Oh, you did too. Look at that. Nice. Okay, so it does work the other way as well. There we go. I'm going to store it now. Next thing is I need to figure out what TO is. So TO is equal to 145 divided by e to the power of 45k. So TO is equal to 145 divided by e to the power of 45 times k. So that's giving me the initial value of 350.17 degrees. Now that I've got that, I can actually go the original equation, which is 40 minus 22 equals 350.17 e to the power of negative 0.196 t. So I've got 28. That's going to get divided, no, not 28, 18, sorry. Divided by 350.17 equals e to the power of negative 0.0196 t. Then ln of 18 over 350.17 equals negative 0.0196 t, and then t is equal to ln of 18 over 350.17 divided by, and so t equals to, let me just see if that actually works out, ln of 18 divided by answer, which is 350, and then that's divided by alpha k. There we go, get 151.48 minutes. Just gonna chuck on a few line numbers here. Yeah, Amy's method works. It does work because she got the right K value as well, and I think it's basically because you're shifting the whole graph by 15 units to the left or right, whichever way it is. Sped test on my website, I've actually put up all the questions that are achieved. That might be a good, probably a starting point for you. What does T naught represent? The chosen one, T naught, I've just written it as T naught, which is the initial temperature. You could actually have any kind of letters in there as you want. Sped test, that's entirely up to you, mate, because look, if you want to pass the papers, you got to do some work, man. You can't just be like doing nothing. If you do nothing, you'll get nothing. Simple as that. So if you do want to do some work, and yeah, give it a go and see how things go. Sorry, George, the question was up at the top there. Yeah, it was to find, what are we finding? How long after the element at 40 degrees. So that's what we're doing. Is it possible to get K first in line 10 to 14? I think no, because we need T naught for that. And I think that's why if you were to use Amy's method, you will actually get K straight away from that. You would actually skip that 11 to 14 steps. Good luck, sped test. Eric, the way it actually works is like, because I see what you're trying to do with KT plus C. Yeah, you could try that. It might work, Eric. I'm not sure. Oh, good to hear, Amy. I didn't see any link, Jake Rowe. No, Daniel, no. That was just in the moment of quote thing. Nah, sped test. Look, I would say, like, if anything, like, maybe do some achieved questions. I think some of the basic tutorials that I did right at the beginning are a good point because they're like quick achieved questions that I do. That might help you. But whatever you do, don't stay up all night and then go and try and attempt 3 papers because that's not healthy. No worries, Jacob. You're welcome. Yes, Ripstick. So Amy's method, if you were to use Amy's method, then that's pretty much add 15 minutes at the end. Just that's it. Which I think it's a very clever way of doing it. Don't get me wrong. I'm going to give full credit to Amy for that one. Line 22. Line 22. All I did was I just grabbed this. Because now I know what K is equal to, I just substituted K in here to figure out what T naught is. Jeremiah, if it works, then yeah, why not? Go for it. Spetes, it's not about making me happy, man. It's you got to do what makes you happy. I'm already happy, It's like so is that the 350.17 is the initial temperature, the T naught. All right, team. Look, that's pretty much me done for the day, folks. I think that's the longest amount of work that I've done for any given day. We'll catch you tomorrow for complex numbers, and I think we've got Chris might have sent us a question. Hopefully, Chris sent us some answers. We're not doing any more Daniel D questions, all right? Because man, that guy just gives us some crazy questions. I'm just trolling, man, mate. No worries, Mary. You're welcome. Yeah, Ripstick, if you use Amy's method, the other temperature, the T naught, will be irrelevant, but it's a bit of a hack, right? So it still does work. Yeah, you got this, Bedluck. Good luck for you, mate. All right, folks. No. You're not banned, Daniel. It's just we need schedule for some of the questions that you sent us because it's like, man, I gotta look through so hardly. Yeah, actually, I did actually sleep very well last night because I think I clocked in about, what did I clock in? What? Yesterday only 1 hour 2 I slept for. That's not right. 3. Nah, 8 hours. 8 hours. 8 hours solid. I need to do a couple of more 8-hour runs and I'll be back to normal. Professional bus driver, absolutely yes. Unless you're absolutely confident that it's an excellence question, I'd always bank a couple of those merit questions just in case. Yeah, Dahlia, that was the first 8 hour sleep I had in almost quite a while, actually. This one would be an E8 question, Tate. All of the calculus questions, like the way they do it is like, if you do a minor error, you can still get E7, but E8 is like fully correct. Nah, Dahlia, I've got proof, man. Like, jeez, these people these days. Actually, it's this week. Where is it? The gray part is my sleep. It's actually above my work, which is good. That's actually starting just Monday. No, professional bus driver. Go for the excellence questions as well, because sometimes you only need like 4 merit questions and an excellence to get an excellence. So keep that in mind. Yeah, E8 is no mistakes. Maz, are you doing level 2 bio and level 3 calc? So oh, that's nice. I didn't. Okay. J-Crow, man, test the run. 20 minutes is all you want to be spending on that excellence question. No more than 20 minutes, because if you spend more than 20 minutes on an excellence question, you cook for time there. Yeah, I was wondering, Dahlia, what you were saying, like you were doing exams. All right, people. Anyway, look, I'm going to go take a well-earned rest and sort out this knee of mine, and then I will catch you guys tomorrow for level 3 complex, and I'm looking forward to some of the questions. Yeah, that's the strategy, Chris. You've got to actually do. I always say to you guys, if you see a proof question, just go for it straight away. Forget about everything else, because proof question is basically they're giving you the answer and asking you to show the answer. And with a little bit of tinkering, I'm sure you guys will be able to get to the answer. Yeah. All right, people. If you are doing bio tomorrow, good luck for that. I needed to actually create a little, what do you call it? Create a little video on Insta and stuff, which I was supposed to post tomorrow morning. I might actually do it tomorrow morning. I'm just gonna go get some sleep, some well-earned rest. All right, team. See you tomorrow. Take care. Catch you guys later. Peace out.